Good day everyone. I will discuss to you the object-oriented programming. The object of this is to understand class object, inheritance, abstraction, encapsulation, and polymorphism. So now let's define object-oriented programming. OOP, it is a programming style that is associated with the concept of class and objects and various other concepts like inheritance, polymorphism, abstraction, and encapsulation. So let's take a simple example to understand about these concepts. Human beings are broadly categorized into male and female. In every human, we have body parts like hands, legs, eyes, ears, and most body parts are the same for both male and female, while some body parts are different. Both male and female performs some common functions. So now, let's use this example to understand the various OOP concepts. Basically, class, it is the design or blueprint of any entity which defines the core properties and functions. Define the attributes and processes. The objects are the instances of the class definition. Example, in the human being class, we have body parts like hands, legs, eyes, ears, and performs a functions like walk, eat, see, talk, and hear. So an important point to be noted here is that the class is just a design where everything is defined, or we can say it is a type. So when we say we are human beings, it means that we belong to that type or we belong to that class. Next is inheritance. A type may include all members from another type or class. Example, considering human being class which has properties like hands, legs, eyes, ears, and functions like walk, talk, see, eat. Male and female are also classes, but most of the properties and functions are included already in the human being class. So they can inherit everything from the class human being using the concept of inheritance. So when we say a male and female both inherit the class human being, we mean that as they have some common features which we have already implemented in the human being class. So we do not have to implement them again in the male and female classes. They can simply inherit them from the class human being. Next is object. An object is an instance of a class that has physical existence. Example, Juan. Juan is an object of a class male. Juan is an instance of class male because Juan is a male, obviously. When we say human being male or female, we just mean a kind or type. Juan have physical existence, while class is just a logical definition. So male is a class which Juan is an object, and object with the name of Juan. Next is abstraction. Abstraction means hiding the details from the outside world. For example, ang properties or ang body parts sa human being class is naka-hide, while ang body functions is wala. So, ang other class nga gikan sa outside world is ma-access niya ang functions sa human being class. Kabalo siya nga ang human being is makalakaw, makastorya, makakita, but wala siya kabalo kung unsaon or unsay gamit sa paglakaw pagkaon kay naka-hide man ang details, ang properties or ang body parts sa human being class, showcasing only the required things to the outside world while hiding the details, hiding the inside mechanism from the outside world. That's an abstraction. Next is encapsulation. Encapsulation refers to binding properties with functions. The wrapping up of data and functions into a single unit is known as encapsulation. It is also known as data hiding. So this is an example of binding of properties. Hand is for hold, walk, and legs is for walk, and so on. Also, in most programming languages, we can declare private variables in class which cannot be accessed outside the class, visible only to methods of own type. For such variable, public functions are defined in the class to enable outside world to access the variables using these functions, and it is visible anywhere. So this is an example of encapsulation. Ang properties and ang functions sa human being class is naka-hide, which is dili ma-access sa class gikan sa outside world. Only the human being class ang maka-access sa iyang properties and functions. Next is polymorphism. Polymorphism means many forms. It allows us to define more one way to do something. Polymorphism is a concept which allows us to redefine the way something works by either changing how it is done or by changing the parts using which it has done. There are two different terms of polymorphism: overriding and overloading. So this is an example of overloading. If we walk using our hands and not our legs, so here we'll change the part used to perform something, so-called overloading. So normally, galakaw ta gamit atong tiil, but gi-change nato siya dani gamit ang kamot. So gi-change nato ang properties, ang tawag ana is overloading. Next is overriding. If the defined way of walking, for example, everyone walks in the direction of their face, what if someone asked you to walk and you start walking backwards? So now you walk, but you walk differently. When you change the mechanism of functions, is called overriding. So kung atong gi-change ang function, ang tawag ana is overriding. And that's all for object-oriented programming. UML activity diagram. UML activity diagram are used for modeling processes. These processes can include different operations within software. They can include software development processes itself, can also include business processes, and other type of process in the example graphic. I have UML activity diagram for simple client-server project in which the client and the server are implemented by different members of the development team. The basic parts of the UML activity diagram include the initial state, the final state, and set of transitions and other state, and control in between the initial state and the final state. The initial state represented by a filled circle and represent the point at which we enter the processes. Initial state indicates the starting point for the process being modeled. Final state displayed by a filled circle with another circle, and this is the state in which we exit the process. Indicates the point at which the process is complete. Remainder of the diagram is located between these two states. In between these two states, we have action state and activity states. Action state represents single operations in the process being modeled. And these operations are not broken down by another activity diagram. Activity state represent longer running process that can occur as steps in our outer process, and these inner processes have their own activity diagrams to explain how they function. Within an activity diagram, we can make a decision to perform one step or another every repeat a prior step based upon some condition. In a UML activity diagram, this decision is called sequential branch. A decision can be taken at the point of the diamond, and then transition leading from the diamond will indicate the next state. Condition associated with those transition are included in square brackets as annotation next to the transition arrows. The special annotation else indicates a path to take if no other condition is satisfied. In modeling processes, it's useful to show where certain steps can be carried out by different people or different components of the system. In parallel, we can represent this in a UML activity diagram by means of something called a concurrent fork. A concurrent fork is simply a thick line to which the transition connects and several transitions originate from the originating transitions we have. States that are reached in parallel, presumably by different entities within the system. Thus, the concurrent fork allows our process to be split into multiple concurrent paths, things that can be done at the same time, and then we can get back together later. In the way we come back together from a concurrent fork is with the opposite of concurrent join. This is the same kind of heavy line, however, transition arrows come into the line and a single transition comes out of the line to the next state. In the sequential process, so we have multiple concurrent parallel paths, meaning to form a single sequential path. Sa concurrent fork, ato siyang split, while sa concurrent join is to combine. It's useful with concurrent fork and concurrent joins to have something called activity partitions or swim lanes. These are ways of annotating the diagram to show which component, individual, or entity is responsible for each parallel path in the project. In this example, we can see the entire team performs research and then performs a design step. Then we have a concurrent fork after which Bob implements the client and Jill implements the server after the implementations is done. We have a concurrent join and come back to the team. Separation of responsibilities is indicated by drawing a box or activity partition around those parts of the path that are responsibility of one single component, one single team member, or one single entity. Let's talk about types of tools that we can use to draw UML activity diagrams. A simple way is to draw the diagrams by hand on paper. If we need a digital copy, we can simply use a camera, such as the type of camera in your cell phone, to make a digital image. Some more professional looking results can be obtained by using a drawing program, Google Docs, drawing, and other general purpose tools, and FUS tools with UML specific additions, DEA, Eclipse with various plugins, and Umbrella. So in summary, UML activity diagrams allow us to model a process. This process can fall into any one of several domains. This could be a process inside software. This could be a business process. In this example, this is a modeling software development process. You can see the initial state, the filled circle at the top, which the development process begins. This process begins with the entire team performing research. Research is an activity state, so it would be described by a separate activity diagram. So in a design phase in which the entire team would be working on the decision for the software. After the design state, we have a concurrent fork, at which point Bob goes and implements the client part of the project, and Jill implements the server part of the project. When both Bob and Jill are finished with their implementations, we have a concurrent join, at which the point the entire team reassembles to integrate the project and test the project. If all the tests pass, we move on the ship state. However, if the tests are not passing, if we take the else branch of the sequential branch, then we go back to the test step. Finally, once we've moved to the ship state, we can move to the final state of the diagram, which indicates that this process complete.
So the next topic is Introduction to UML, or also known as Unified Modeling Language. So this would be the overview of Introduction to UML. The things that would be discussed are the following. The first one is software modeling. Next is UML, limitations of UML, UML diagram types, role of UML software engineering, and case tools. What is UML? UML is a unified modeling language. It is a modeling language used by software developers. UML can be used to develop diagrams and provide users or programmers with ready-to-use expressive modeling examples. Some examples is UML diagram types and use cases diagram. So what's inside the UML is that it is showing the system classes, their attributes, operations or methods, and the relationship among the objects. And the importance of UML is it is powerful enough to represent all the concepts that exist, object-oriented analysis and design. So next is the model of software systems. So in modeling software systems, especially complex systems, it is useful to be able to present a design other developers for discussion for the developing process. So that is why complex software systems need to be designed before construction or modification. Next is need a way to communicate the design to other developers and stakeholders in the system. So it is very helpful to have some analog to constructor's blueprint. Consider, for example, in the real world is building a hospital for architects, which architects draws a high-level design. Engineers design the parts of the building, and during construction, the designs are updated for changes and problems encountered. And finally, after construction, the blueprints are retained in case an addition is needed later. So for software engineers, Unified Modeling Language provides an option for software engineers to have a similar design documentation for software projects, which means for software engineers, UML serves as the blueprint for their software projects, and for the architects, blueprint serves as uh, the construction of building a hospital. So next is the Unified Modeling Language. So in the early days of software engineering, diagrams were drawn using a variety of different formats. So these formats consist of different symbols, connectors, annotation, and etc. So developers moving between companies were trying to collaborate company or even divisional boundaries of a company, and to be trained on each specific format was used for communication. So the idea behind the UML was to provide a single standardized formatting and standardized set of symbols in order to create a common language. So the folks who did this were Grady Bush, Eivor Jacobson, and Jim Rambo. So these three were the team at Rational Software Corporation, which was later purchased by IBM, or also known as Internal Business Machine. So UML as a standard. So UML was standardized by the Object Management Group, but standards are not always followed by UML tools, and also no set of tests to verify compliance. However, UML has become popular for drawing certain types of diagrams manually, by hand different tools or electronically tools. And lastly, UML provides diagram types of model system structure, behavior, and the interaction. So, limitations of UML. UML does not replace other types of design documents. Example is use case diagrams relate actors to use cases, but they do not replace use cases. Also, many of the diagram types are not widely used UML diagramming tools, often incompatible with each other. And lastly, standardization was controversial. Other software modeling approaches exist but are not included in UML. So, in use case diagram shows business or system which serves as its external users, while in use case it represents one specific goal or need of the user from. Next is UML diagram types. So UML does provide a rich variety of diagram types. These can be classified into 2 to 3 categories depending on you prefer to draw the classification. So we have here is the structural diagram, in particular the class diagram that are widely used to show how object-oriented is designed. And the other side is behavior diagram, in particularly in activity diagram, shows how a development process can be coordinated. And state machine diagram, which is useful for representing finite state machines that exist in many types of software. So UML in software engineering. UML is one of a number of tools used to plan, architect, and design software applications. Next, it is a diagram using UML are convenient for communication between different members of a development team. Lastly, design documents using UML help communicate the architecture and design of an implemented software system to future developers who maintain it. So, case tools. So, there are some tools available again. So, case tools. So, there are some tools available called case tools, or also known as computer-aided software engineering tools, which they can take UML diagram about further and actually generate partial program code from the UML diagram. So some tools are capable of translating certain types of UML diagrams to partial program code, and other tools can generate diagrams from existing code. Next. So use cases. Next topic would be the use cases. So what is a use case? It is a written description of how users will perform tasks on your website. It outlines from a user point of view a system's behavior as it responds to a request. And lastly, it is represented as a sequence of simple steps beginning with a user's goal and ending with when that goal is fulfilled. So, this is the example of what use case diagrams looks like. So, use case diagrams model the functionality of a system's using actor and use cases. Use cases are a set of actions, services, and functions that the system needs to perform. In this context, a system is being developed or operated, such as website. The actors are people or entities operating under defined roles within the system. And why use case is important. The importance of a use case diagram is to capture core functionalities of a system and visualize the interaction of various things called as actors with the use case. This general use case of use case diagram, the use case diagram represents the core parts of a system and workflow between them.
So next is requirement analysis. So use cases are one type of requirement document which they provide a written narrative that describes how the system under discussion or SUD will behave under given scenarios. So the first one is the use case. It's a requirement document, and after implementation, the SUD or system under discussion could be tested by the following use cases, use cases and checking its behavior. So other types of requirements document exist. Use cases provide only some of the requirements. And it is important to remember the use cases is only a one type of requirement document. Other types of requirement documents such as system conceptualization or user specification do exist. Next is use cases. So the primary function of use case is to describe how a system under discussion or SUD responds to interaction from stakeholder in a system. In other words, specifies what the system under discussion is to do in different scenarios. So there are level of the use case varies. The first one, at the level we have high level, we have business use case that describes business process it must be carried out without specifying any technology details. These use cases are also called essential use cases. At the lower level use cases, or the system use cases describe how the SUD will behave in specific. Next is the scope of use cases. Use cases may either have black box or white box scope. All business use cases and many systems use cases use black box scope, which means they treat as mystery device. They specify how the system will behave under given condition. Some system use cases may be written from a white box scope, which means these use cases detail some of the internal operation of the SUD, such as specific protocol or algorithms that will be used. White box cases are especially useful describing how different components of the SUD will operate in one.
So UML state diagram. UML state diagram provide a way to model the behavior of a system by analyzing how the state of the system changes in response to input data. So basically, it is the way to model behavior of a system. So as you can see, we have a sample model of a system that captures the user entering a number consisting only of the digits 0 to 9 and at most 1 decimal point. Sumopen ang sumopen or mo-finish ang system whenever ang system mo click sa enter key. Invalid key strokes are simply ignored. Based on the diagram, the user has entered only numerical data. Understanding how the state machine operates, how UML provides us with convenient way to draw state machines requires some explanation. So state of software system expressed at any given moment in time as the current value of variables in the software. For object-oriented systems, each object has state stored in the object's variables class fields. As software executes, component change state. state changes are essence of computing. A computer is a machine with an extremely large but finite number of states. Programs move the system between states to accomplish tasks. So, in general, a state is a data or information na ma-change or manipulate throughout sa runtime sa code or program to accomplish a task. So, next is the finite state machine. Conceptual way to model a software system. System in any one of a fixed number of states and can move or transition from one state to another. Upon entering a state, existing a state, or making a transition, the system can produce output. It input and output are conceptually modeled as tapes or strings of data, words from the alphabet that can be read and written. Final state automaton has single input tape and accept or reject the input. Finite state transducer can write output to a second tape. Ang pasabot aning last means na a set of characters that machine knows how to write and read is ang alphabet. So, ang word na ma-form aning alphabet creating a language is ma-recognize siya sa state machine. Next is natay ginatawag nga finite state automaton which ang iyang tape ra is maka-input ra. Next ay ang finite state transducer which na maka-input siya o maka-output siya. So as you can see, na siya isa ka bangag which is na mo accept siya or mo reject. While ang finite state transducer which is finite can write output to a second tape. So as you can see, pwede maka-reject o maka-accept ang finite state transducer and maka-release po siya output. So a state machine can be either deterministic or non-deterministic. In deterministic algorithm, for a given particular input, the computer will always produce the same output going to the same states. But in case of non-deterministic algorithm, for same input, the compiler may produce different output in different runs. As you can see, there is an example. Ang deterministic algorithm is unsay ang gibutang sa input is mao pud ang output. But sa non-deterministic, if unsay mong ibutang diri nga input, na possibility nga different iyang output. As input to the deterministic FSM is read, the machine transition from its present state to another state based on the input data. State machine can produce outputs either only upon entering a new state, more machine, or any time within state transitioning to other state milli machine. So, which is na ma-explain siya later. More machine, ang pasabot niya, ayara siya mag-produce og output if makaato siya sa new state. So, let's assume na ang 0 is ang output ug 1 ang input and kaning lingin is ang state. So, if mag-input ko diri sa isa ka state, means na mo-release siya output. If mag-input na po ko aning isa ka state, mag-release na po siya output. If mag-input na po ko aning state, mag-release na po siya output. So, next is ang milli machine. Which means na makaproduce siya output within the state or transitioning to another state. As you can see, there is a sample graph na to. There is a input nga part is na siya 0 ug na pud siya 1. So, diri nga part is na siya possibility na mag-release siya output and mag-input siya sa another state which is na napoy possibility na mag-release pud siya output. When an FSM transition to another state without consuming any input data, the transition is said to be non-deterministic, is called lambda transition. Next is the power state machines. Deterministic and non-deterministic FSMs are mathematically equivalent, neither is more powerful. All FSM can recognize any set of inputs known formally as language that can be modeled by a regular expression. More powerful machine exists, which is the push-down automaton FSM with a stack handles context-free languages, linearly bounded automaton PDA that can move back and forth along the input tape, handles context-sensitive languages. Next is the UML states diagram. So it is a type of behavioral diagram model deterministic finite state machines, Moore and Mealy model, generally used to model the behavior of single objects in system under discussion with multiple diagrams for multiple models. So next is the initial and final state. Represent entry and exit points for diagrams. Initial state is represented by inanning a shape and final state represented by inanning a shape. So as you can see, mo ni example sa initial and final state. So sa initial state is mag-start siya sa enrollment, padulong siya sa being taught, but if the student drop is mag-start siya, and if maka-seminar na rin siya, pumabalik siya sa being taught. If ever na wala siya na drop, paingon siya sa final exams. And pagka-human sa final exam na yun, diyan na rin mag-close and mapadulong na rin siya sa final state. Next is the internal state. Intermediate state in system are represented by internal states. Rounded rectangles may contain a name and a set of activities to perform in that state. So, as you can see, nata example diri, which is ang left side is ang condition and ang right side is ang activity. Next is ang entry and exit action and activities. The system can produce output or perform activities within a state or when transitioning to a new state. Entry action, taking upon entering a state, exit action, taking upon leave state, do action taking a while in state. So basically, kung mo entry siya and while naa pa siya ana nga state, is mo execute sad tong do na condition, and if mo exit siya, is mo leave siya ana nga state. Next is the transition. Transition arrow connect state together. System follows the arrow to move one state to another. Arrow's annotation have the format trigger guard action. A transition is taking if the trigger is matched and the optical guard expression evaluates to true. Upon making the transition, the system can take some actions such as product producing output. So as you can see, during a diagram, which is na ang pasabot ani is if ma-detect niya nga ang value is from 0 to 9 is mo open ang next is the nested state machines. UML allows the state machine diagram to be nested within a state outer diagram. So as you can see, nata example diri nga diagram which is na ang isa ka state is na siya isulod nga isa ka diagram set. Thinner to have an external state diagram and use a special symbol to indicate that the state internals are documented by another diagram. So next is ang UML state diagram. Graphical way to illustrate relationship between classes is an object-oriented system. Appearance varies between different drawing tools. Round-trip tools are able to generate UML class diagrams from existing code and generate template code from existing diagrams. catch diagram must be stored in a format can import. So, morning sample sa class diagrams. So classes. In the simplest case, a class be a box with the name of the class included within it. Class. Next is ang class fields. Class fields, data members of a class are added to the box between two lines. First character in the field gives scope. So, if ang field is public, makatag siya plus sign, and if private siya, is minus negative sign. Types indicate pure UML language and is independent. Many tools are language dependent. Next is ang methods. Method member functions go below the class fields sections. Methods members functions go below the class fields sections. Same scoping and typing conversation use actual semantics vary from tool. So basically, method is an action na execute ang object na iyang nadawatan. It also an acts on data and may or may not return a value. Kaning naka-underline is maunang ang static method kay stand alone without having to be called from an instant, which is na kaning main args, which is na ma-execute na siya even though nga dili na siya tawgon. So next is ang relationship between classes. Drawn using arrows to connect classes together. And nani siya duha ka categories. First is it can represent relationship between the classes themselves, which is ang generalization, and next is ang can represent relationship between instances of the classes association. Each relationship and classes and a class diagrams can have multiplicity numbers assign one or both ends of the line between the classes. Next is ang municipality. Can consist of a single number such as a specific number, range of numbers, unbounded and unbounded ranges. So, let's proceed sa mga category. First is ang generalization. Shows is a relationship between classes which use for languages that support inheritance. Child class is a subclass of a parent class. So in this example, as you can see in the diagram, ang simple message is ang child class sa message na ang parent class. So next is ang association. So ang association is naa siya duha ka subcategory. So first is ang aggregation. Weak type of has a relationship. One class contains a collection of instances of another class. Key idea: the instances of another class can exist independently of the collection. So this example, kaya ang multi-message na nag-act as a ga-collect siyang message from the simple message class. Ang indicator sa ani niya is kanang hollow diamond. Next is ang composition. Strong type of has a relationship. Class contains one or more instances of another class, and the key difference is from aggregation. Aggregation is the instances cannot normally created by the container constructor and destroyed by its constructor. So, in addition, ang composition has a parent entity owns a child entity, while ang aggregation parents has a relationship with the child entity also indicated with a field diamond.
For Module 3.3, we have modeling concepts. So first, what is object-oriented design? It is mainly the process of using an object methodology to design a computing system or application This technique enables the implementation of a software based on the concepts of objects. General objective. The general purpose of object-oriented programming design is to increase or provide modularity to software by breaking large software systems into smaller pieces. This approach to software engineering improves code maintainability by separating from each other or breaking code into multiple components. Also, these components may be reuse of existing codes or any other software applications. Idea behind objects is the real-world process can be reflected in software components. Example, we have a song player object. Most in a physical machine, we have wire, disc, different buttons, and etc. But when it comes to digital music, this process was moved into software. However, the basic operations of playing, pausing, stopping, moving forward, moving backward remain the same in an object-oriented design. Both song file and play control methods fit together logically as a single object. Both the data required to produce the sound that comprise the song and the behaviors required implement the song listening process are grouped together in a logical unit, and this logical unit is what we call an object in a software systems. Object-oriented design versus object-oriented language. An object-oriented design is a language-independent. Implementation language doesn't actually need to be object-oriented as long as the programmers maintain proper discipline, while object-oriented languages attempt to make it easier to implement object-oriented designs. However, it is possible to implement a function-structured program in an object-oriented language. To make it short, in an object-oriented system design, it helps in designing the system architecture or layout, while the design system is later created or programmed using object-oriented based techniques and or an object-oriented programming language. Components of objects. The key concepts behind an object is that it combines a representation of data in a system along with algorithms to access, manipulate, and perform operations on that data. The data are encoded in an object using properties. Properties are also known as fields. It stores information about the object. The combination of the values of these properties is collectively form the state of the object. While for methods, an object's behaviors are implemented as functions that are bound to the object itself. In object-oriented terminology, these functions are called methods, although C++ retains the older terminology of member functions. Also, methods perform operations on the object. To make it short, fields are what the object's information and methods are the performing action of an object. For example, we have cat class. It has private fields, namely as mood, hungry, and energy. Also, it has three methods you can call: the feed, sleep, and play. During sleep, the action would be the cat's energy will increment. Also, the cat's hungerness will also increment. During the play, the cat's mood will increment while its energy will decrement. And lastly, while feeding, the cat's mood will increment while its hungerness will decrement. Another definition of an object is that objects are instances of classes. Classes is a programming structure that provides templates and specify how objects are gonna be constructed or created. These classes defines what properties and behaviors will object would have once it is instantiated. Granularity. How data and behavior are divided among objects. The level of which these divisions occurs is called granularity. There is a direct relationship between high granularity and the total number of objects in a system. Achieving the correct amount of granularity in an object system design is a balancing act, or it must be in a balancing act. If it would be too much granularity, the system will comprise of many small objects. These type of software projects becomes overly complex and hard to develop. Furthermore, due to the nature of underlying operations needed to create, manage, and destroy objects, the execution software performance of an object-oriented application will decrease as granularity increases. Also, because the project becomes overly complex or hard to develop, it will also be hard to maintain, or its maintenance will be difficult. At the opposite, if there is too little granularity, there would be several huge objects. If the code is not modular, possibly more prone to bugs, as it would be difficult to debug, so the maintenance will be difficult. Objectives of objects in theoretical. No one has ever seen to agree a concise objective of an object-oriented design, but for now, we will be using Cabe Horstman and Gary Cornell in providing the objectives in encapsulation, information hiding, polymorphism, and reuse. Encapsulation. For encapsulation, data and methods stored together with well-defined interfaces. Data and methods operated upon a data are stored together in an object. These elements are accessed via well-defined interfaces to the object. If it is in the outside entity, it can only access fields directly. For information hiding, code that uses an object should know nothing about how the object works internally. Other programmers can be given an interface to an object without revealing the implementation code, preventing them from using shortcuts or making assumptions that may later break when the object is updated. These information hiding works may also be called as black box, or we can relate it to a black box because it has behaviors but its internal workings are mystery to the outsiders. For polymorphism or polymorphic interfaces, different classes of objects that have compatible interfaces can be used interchangeably. As example for polymorphism, we have a class shape area, and also we will create a 3 different class which is for the area of circle, triangle, and rectangle. And lastly, reuse. A well-designed, tightly encapsulated objects can be reused later either in the same program or another application. In theory, over time, the collection of well-tested objects will provide a development team with a library of useful components that can speed the development of new applications. Of course, there is a downside to any development approach, and object-oriented design is not exempted to this. Developers working on object-oriented designs has a tendency to running up the design, creating a terribly over-engineered massive code that add unnecessary complexity to a program. Another issue is that, in practice, reuse of objects in a later program may be difficult unless the new program is nearly identical problem domain as the original program. Also, another issue for object-oriented design is that it is slower to execute. A major cause of this performance is that objects are typically allocated and deallocated from heap memory, and we know that heap memory is a hierarchical structure which the larger it is, the slower its action gets. And also, heap takes too much time in execution. Also, it is not suitable for performance critical situations like an operating system kernel. For 3.4, it is entitled as UML 2.0. What is UML 2.0? UML 2.0 is a revision to Unified Modeling Language that incorporates several improvements to UML. UML 2.0 is only just now beginning to supplant UML as the de facto standard. De facto means denoting something existing, actual, or effective. Also, it is designed for more rigor of specification, and it can be sometimes be too much or too much of a fine-grained distinction to bandy about when it an actual day-to-day working software development environment. The improvements to UML 2.0. First is that new base classes that provide the foundation of UML modeling constructs. Number 2, object constraint language, a formal method that can be used to better describe object interactions. And 3 is that an improved diagram meta model that allows user to model systems from 4 viewpoints. First is that static models. Example for static model is a class diagram where it describes the structure of a system by showing the system's classes, their attributes, operations or methods, and the relationship among objects. For B interaction, an example to this is a sequence diagram. It depicts the object involved in the scenario and sequence messages exchanged between the object needed to carry out the functionality of the scenario. For C activity, the example of this is a activity model. Um, Activity model describes the flow of activities within a system. For D state, an example of this is a state diagram system. A state diagram system are composed of a finite number. And for an example to a state diagram system is a finite state machine. An example of a finite state machine is vending machines.